In this video, we shall be solving this system of linear equation using elimination method. Of course, in our previous video, we had solved this same system of linear equation, this same problem, using matrix inversion method as well as substitution method. Okay, so the third method is to use elimination method in solving same problem. So this time around, we want to use elimination method. Now, to solve this system using elimination method, what we first do is to eliminate variables, the variables step by step until we find the values of x, y, and z. So first step, let's eliminate x from the second and third equation. So this is the second equation, this is the third equation. So in order to eliminate x from this and this, we need to multiply the first equation by 2. So when we multiply the first equation by 2, we get this. So we then subtract the next equation from that. So when we do that, you subtract the left hand side from the left hand side, you subtract the left hand side from the left hand side, and you subtract the right hand side from the right hand side. So this time around, what we are doing, we are subtracting this from this. So and that is why you see this coming first and this coming second. And that is why you see this coming first and this coming second. So you subtract the left hand side from the left hand side, and you subtract the right hand side from the right hand side. And that is what we've done here. So playing around with that, 2x minus 2x will give us nothing. So minus y minus 2y will give us minus 3y. Then 3z minus times plus, of course, will give us minus. So that would be minus 3z, plus 3z minus 2z. That will give us z. That's plus z. So 14 minus 12 will give us 2. So the second equation then becomes minus 3y plus z equals 2. So instead of this is what we've got now. Now the next step is to multiply the first equation by 3 and subtract it from the third equation to eliminate x. We want to eliminate x from these two. So we'll multiply this by 3. So when we multiply this equation by 3, we have this. So and when we subtract it from this, we want to subtract this from this. So, and that is what we have tried to do here. We've written down this, what is on the left hand side minus what is on the left hand side here, and what is on the right hand side, which is 1, minus what we've got here, minus 18. So 3x minus 3x give us 0. So we have successfully eliminated x from the third equation. So then 4y minus 3y gives us y, and minus z minus times plus gives us minus. So we have minus z minus 3z, that will give us minus 4z, equal 1 minus 18, of course, is minus 17. So this is what then occupies the third equation. So the third equation becomes this. So what we then do is that we can then solve for y and z using the new equation, using the new second and third equation, which is this. So again, we can use elimination method. So how do we eliminate? We now want to eliminate y. So how do we eliminate y? We multiply the second equation by 3 and add it to the first equation to eliminate y. Of course, when we multiply 3 to this equation, it will give us 3y minus 3 times minus 4 will give us minus 12z, and equals minus 17 times 3 will give us minus 51. So when we multiply 3 by this equation, we have this, and we can now add it up to this. So that will give us minus 3y plus this equation basically. So this is it. So when we want to add this and this, what is on the left hand side is added, what is on the right hand side is added. So minus 3y plus 3y gives us 0. So z plus times minus will give us minus. So z minus 12z will give us minus 11z equals 2 minus 51 here will give us minus 49. So z equals 49 all over 11. So we can then substitute this back into equation 4. Basically any of the equation, but this will appear simpler. So we can substitute z into equation 4 to determine y. So, and that is what we've done here. You can see y minus 4 into brackets. We substituted this for z, and we played around it sufficiently to determine y, which equals 9 all over 11. And we can also substitute 9 all over 11 for y and 49 all over 11 for z, and substitute into any of the earlier equations to find x. And of course, this is the first equation, which, well, may be the simplest to substitute these values into in order to get x. And that is what we've done here. And well, playing around the equation shows that x equals 8 all over 11. So you can see then that x equals 8 all over 11, y equals 9 all over 11, and z equals 49 all over 11. So looking at the solution, you'll find out that the answers gotten using elimination method is the same with the answers gotten using the substitution method as well as the matrix inversion method.